Hi, this is Sorendil, and this is my Sprint2 project demo. And what we're looking at right now is, as you can see, I had an old backlog here that was used in the last demo and turned in, but this is my adjusted backlog after having worked on the project some and seeing sort of what is required to do what I wanted to do. It turns out it's more complicated than I originally anticipated, which I think is pretty common for developers working with new software, new technology. But especially for novice developers like me, I think that underestimating what is required is probably pretty common. And that's what I did. And I'm not going to get into the specifics of everything that's different on this backlog because of time constraints for the video. But what I will say is basically I've unpacked a feature or two and also elaborated on the overhead, like what libraries I need to learn to do what I want to do for this project. And I've adjusted project Sprint 1 to reflect what actually happened during Sprint 1. And the real big takeaway here is these backlog items pertain to overhead of learning jOOQ and MVC. And this backlog item pertains to a feature that I sort of unpacked from another feature, which is the ability to browse what games are in my database. I was trying to figure out how that fit into what I originally handed in, and I don't think I really had that feature. I had the ability to view success metrics for games, but I didn't have the ability to just look at a table of the games, which I think is pretty important because of what I'm going to do next week, displaying the success metrics. I think people will maybe want to be able to unpack those metrics a little bit, and the way to do that will be to browse what's in the database. So that's what I'm going to focus on this week. That's what I did last week. I did browse by title, essentially. And this little note here is kind of important because of the focus of the class delivering user-facing material. I've reprioritized backlog items, and that applies to all of my sprints. So I'm focusing on stuff that I can show you, pretty much, instead of something like a read request for a JSON payload of the data. So here we go, backlog item number 7 again, which basically has to do with fitting Spring, jOOQ, and Vaadin together to present a data-driven view from my backend, from the backend underlying this project. So that took some time. There were some complications there, a little learning, and then once I did learn what I wanted to learn, you can see here that when I tried to create my first new feature of the week, which is to browse by genre, it took a lot longer than I thought it would, because even though I had learned the fundamentals of how I was going to do what I wanted to do, it didn't work that way, and I ended up having to do something else, a few different workarounds, which I'll talk about when I show the code. And so I created new features for genre, language, and user tag. How are we doing on time here? Okay, a little over. We'll stick with that. So let's show you those features. Browse by genre. Okay, so let's start with lang. So this is browsing by language, and what you're seeing right now, there are 127 games in my database for reasons I'll get into later after I'm done with the official part of this. But there's 500 rows here, and that's because games support multiple languages, so they're duplicated just like they would be in a SQL query. So let's start with English, the most popular one, as you can see. And that makes sense because Steam is primarily a English-speaking platform, although it is popular in other places like Russia. And so let's see, these are the games that support simplified Chinese, and you'll see some games like appear on almost every list, like novice and Argo. And and by the way, you can sort these just by clicking, just like you would in any other table. But anyway, the reason those games appear in every list, I'm guessing, is because they have a major publisher behind them. I do not have the ability to sort by publisher right now because it would be almost meaningless, because almost every game in my database is self-published by some small indie developer. So I would be presenting you a table without much meaning behind it anyway, if I were to sort by publisher. But as my database gets bigger, I will add that feature to this API. So simplified Chinese, those are the games that support simplified Chinese. Here's traditional Chinese. I don't know what the difference is. I don't really know that much about Chinese. but fewer games support it, as you can see. Again, Argo and Nongos are here. They're kind of in, Argo's not, but Nongos is in almost every list. Well, make me look bad here. But anyway, so I think that's what it is. A lot of these games that appear on a bunch of lists are probably published by a major publisher. So let's look at title by genre. That's, again, pretty intuitive, and you've got the same thing here. Probably 300 rows for 127 games, and that's because games can have multiple genres. This list and all of these drop-down menus are populated dynamically, so if the genre, in this case, is in my database, it will be in this list. And so these are simulation games, and you can sort by any of those things. Right now I have it only set up to display these three fields, but I can change that just depending on what kind of user feedback I get. So yeah, and different genres. So let's look at tag. Tag is kind of the most interesting one. It's the most interesting pivot point to me, and that's because it's user defined, so it's very dynamic. Of course, because it's user defined, it's also like invites basically all sorts of hooliganism, kind of ridiculousness from the public. And we have a pretty clear example of that here. Really the only game that has legitimate tags, because I'm focusing on new releases, and I've set basically a threshold that a user tag has to meet before my database will accept it. It's a number of user votes, essentially. So the only game that I have actually scraped so far that meets that threshold with any tags is Argo. And I haven't looked at Argo. Love the movie. I don't know what the game is. Apparently it's a free-to-play shooter action. Faster Than Light, I put the game in here manually, and then my code automatically scraped the tags, but it is not a new release. So, but there is another game in here that is not legitimate. These tags are not legitimate. This B game. Let's just use the drop down and say it's tagged as psychological horror, nudity, and sexual content, and that's pretty ridiculous because what this game is, if you go look at it on Steam, is a bumblebee simulator. It's literally you fly around a spring valley as a bumblebee, and as far as I can tell, there's nothing else to it. It's certainly not a psychological horror, and it's not. There's no nudity or sexual content. So something happened. I don't know if it's bots or if someone did it and then people thought it was funny and kept doing it. But 400 people have voted for each of these tags, which is very ridiculous. So yeah, it brings up another problem for my backend that I'll talk about later. But okay, we got 2 minutes left. So let's look at the code. So my code is structured with database utilities that essentially are the business logic, container objects, which are data transfer objects, and there's two types of these. There's jOOQ generated ones, which only are useful if you're querying data from a single table in my database. Otherwise, I have to create custom POJOs, and I'll show you what one of those looks like. Let's say title language. Very simple object. It just has three. Right now it has three because that's all I wanted to transfer. 3 fields, 3 attributes, and each one is tagged with a JPA annotation, and this explicitly tells jOOQ where to map the fields from the query to in this object. And it's not strictly necessary here, but it will help avoid complications later when these objects get a little more complex if I use them to transfer other data. So that is what my data transfer objects look like. Let's look at the business logic first, the database utilities. They're all structured this way, very simple. They have the component tag, which tells, what it actually tells Vaadin is that this is a component that can be used as a data stream for a Vaadin object, a Vaadin display, essentially. And it does that with the Spring Framework component tag. I couldn't find any documentation that says specifically that this will work, which makes me a little nervous, but it does work. So I guess I'm not going to question it too much for now. There is also a Vaadin UI component that doesn't extend to this Spring Framework component. So I'm just not sure exactly why this works, but it does. Obviously, I haven't imported the Vaadin UI component, so I'm not using that tag, that annotation. So anyway, the way it's structured, empty search, a search with no arguments returns all titles and tags. This this method is used to get a list of all the tags in the database for the drop-down menu. And then a search with an argument will use a where clause on the SQL, which you see right here, to filter essentially the results based on the drop-down menu item you selected. And we'll look at the view and see how it's functioning. And again, all of my views that I created this week function the same way, basically. They specify a Spring UI path, so it tells Spring what URL to put this UI at relative to my application context root, which since it's Tomcat, it defaults to localhost port 8080 /, and so that's where you're finding this and why you're seeing it that way in the browser. As you see there. And so let's see, I talked about AutoWired last week. So what you're seeing is I'm telling Vaadin, this is a Vaadin grid now, and I'm telling it that it's going to be a grid of this title tag object, which I already showed you a custom Pojo, and it's 3 variables. That's all with getters and setters. That's important for Vaadin, actually, getters and setters. But you'll see in the init method, it takes a request, a Vaadin request, which is really just a wrapper for an HTTP request, and it displays a combo box with the caption set a user tag, and it pulls from the tag query object, the database utility, the get tags function, which is that list of all the tags in the database, and uses that to populate the drop box or the combo box. And then it has a change listener, so whenever you select a new tag, it will immediately update it call this update grid function, which just passes the tag into the search function, and then updates whatever the search function returns on the grid. And then the other significant thing is this grid set columns, which is actually redundant here because those are the only 3 variables in that Pojo, that title tag Pojo right now. But if I added variables later and I didn't explicitly say which 3 I wanted, it would automatically display those. So if I'd added something that was sensitive, or I maybe didn't want to show the world about how my database logic works, it would just show it unless I specifically tell it what to show, which I have done here. So that's pretty much how it's working. And now I'm sure I'm out of time. I am, so I'm over time. So I'm going to talk just a little bit about some of my problems and stuff. You can kind of count that as like, okay, that's it, if you want to tune out at this point. But some of the problems I'm running into, the biggest one is that when I started this, I planned to do this project on top of another project, which was a personal project of mine. And I thought, because I didn't have an internship lined up, that I was going to have a lot of time to work on that project. And then suddenly, like on May 5th, I landed an internship. And so I haven't had nearly as much time to work on that project as I wanted to. So I basically, instead of setting it all up on a DigitalOcean server and letting it run on cron jobs, I'm running it by hand, which is, not ideal. And I've just had a bunch of like sort of unanticipated problems with type errors and I don't know, all kinds of stuff. And that runs on Python code, the code to scrape all the data into my database, which is a Postgres database. And then specifically with this, I've had problems that were created by type errors from my database. Like jOOQ was expecting a certain type, specifically date type errors, and the money big decimal wrapper from Postgres, which I think is actually originally from MySQL or something, caused a lot of problems. And jOOQ has been pretty disappointing. I spent probably more time the thing that took up my most time individually was trying to get jOOQ to generate records for cross-table displays. Like, so when you're joining a table, the jOOQ records can't really handle that. Like, there's a way to get it to happen using a custom record mapper and my CodeGen thing, but I didn't see any advantage to using it because the code for the custom record mapper was going to be pretty complex, and also I couldn't guarantee that it was going to do what I wanted it to do. So yeah, jOOQ's been a little disappointing, I would say. I think maybe I was just expecting it to ease things that can't be eased about using SQL as a backend, and I'm not sure I would use it again. I feel like having to create custom POJOs as data transfer objects is kind of and the way these jOOQ queries look is like it looks almost as ugly as a JDBC SQL query, really. The only big advantage I'm seeing so far is that because jOOQ automatically created these fields, my IDE can auto-populate them. But yeah, so those are some of the problems I've faced and continue to struggle with. And obviously, I just didn't know fully what I was getting into here. But I hope that was informative, and I'll talk to you again in 2 weeks. Have a happy 4th.